Hi, everyone, welcome. This is Gate Study Circle session, and today it is led by Nikhil and Jaimit Osawa. Both of them are focusing on the logic gate circuits and all. So let's have Nikhil start the process. Thank you.
Yes. Uh, uh, in the session that we had 2 weeks ago, I had explained uh, the theory of calculating or how to proceed with the numericals in digital electronics or data logic and circuits. Mostly in uh, this technique is useful in combinatorial circuits in digital electronics. Uh, so we are planning to take up some numericals based on digital logic today and try to solve some things as fast as possible and try to explain the uh, concepts behind those through some questions that have appeared already in previous GATE exams. So here we have a question number 235, if you could see. Right. So 225 here says there is a K-map of a Boolean function and there are five variables PQRS and X. And we have to find the minimum sum of product expressions for the function. Sorry, is yeah. So we have to find the minimum SOP expression of the function. This is what they have asked. We are expected for to find the minimum SOP. So minimum in the sense that it will have the least number of SOP terms. Uh, they are not expecting a canonical form, but a minimum SOP function. So what we have here is PQ and RS. The X is the output. Building a K-map is very easy, but we have to keep one thing in mind that at a time only one bit changes. So in the row header and the column headers. So basically, what we are going to do is start with 00. We start with 00 and then change one bit at a time. So this is a 01. Uh, Now the next header would be 11 and the last because we are just changing one bit at a time and the last element is 10. So we have covered all the four possibilities in two binary digits. Similar is in the column headers. We do 00, 01, 11, and 10. Uh, I'm just copying the question again in this schema that we have created. When x is 0, okay, so this is when x is 0, and the second part is when PQ and RS when is x is 1. Uh, we can also compile these two k-maps into a single map with uh, with a single variable. But doing this would require a lot of practice. Uh, say PQXRS. What I'm okay, sorry. What I'm trying to do here is now let us see. Uh, Let us see how we can create a system where only one bit changes at a time. So we can do it this way: 000 001 011 010 110 111 101 100. The basic funda behind this is you take you try to flip the least digit, the rightmost digit. So I'll do it again: 000. So if I flip the rightmost digit, I will get a 001. This is okay till here. But now coming to the next increment that we have, if we again flip this rightmost digit, the binary rightmost bit, we would again go back to 000. So in that case, we take the next digit, next binary digit that is available, and just flip it. So here we have switched the middle digit, the second from right, and we get 0 0 1 1. Again, by the rule, first we try to check the least bit or the rightmost bit, and if the number has not occurred earlier, we just switch it again, which gives us 101 010. By the same logic now, if we switch this, we have already got the number. If we switch the second bit also, it will give us 000, which was the number that we had started with. So the next option is to take the next most significant, least significant bit. So it is this one, the third bit from the right or the first bit from the left, and we just switch it and keep all the digits as the same digit. Again, switch the least significant bit. If we switch the list here, if we switch the least significant bit, we again come back to this number. So we take the next bit and change it. And if we switch the least significant, uh, we have not got that number earlier. So this is what we get. So this is how we have calculated this sequence that will come up in the row headers. We just copy it from this. So we have x as 0 in here. This is x and 0. We have x is 0 here, and we have x is 0 here, and x is 0 here. We just copy these things over here. 0 when x is 0 is 0 1 1 0. Uh, 0 0 1, right? So if we ignore the least bit, which is x, the value for x, we have 0, 1. So we copy the row from 0, 1 where x is 0 into here, and we just copy the entire uh, column. 1, 1, and 0. So 1, 1, 0 is here, which is all zeros. This will be 1, 0, and 0. So 1, 0, 0, 0, the row will be, the column will be 1, 0, 1, 1, 0. This is 1, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. When x is 1, this will be 0, 0, 1. So we copied this row, this column into 0, 0, 1. It's all zeros. The next one is 0, 1, 1. Yes, 0, 0, 1. The next one would be 1, 1, 1, 1. This one 0, 0, 1. And the last is 1, 0, 1, which is giving us 0. Here we have this block, which is x is 0, which is actually as same as this thing. We have, what we get is this. mm, Uh, the rules for such is that what do we have common here is 0, 0, 0, and in and here what do we have common? Let us see what we get: 0, 1, 1, 0, and this column is 0, 0, 1, 0, 0. So uh, the common thing is 0, 0. So in case of q bar, x bar, q bar and x bar, because this is p, q and x, this is also p, q and x. uh, One denotes that it will be the root variable. A 0 indicates that it will be an inverse variable. So 0 here under q means it will be 0 bar, and for this not for so this is q bar x 0. It means 0, 1 for R and S. So R is R bar if we are considering this term, which is R and S. So it should be R bar and S plus. We are now considering the second term, the lower term, which is R, because the variable under R is 1. The value of R is 1 here, and S is 0. So this should be S bar. This is one term what we have got. The other terms here are okay. I think we can calculate from here. This unit again itself is PQ. We have this term, so which comes as x will be 1. So this is x multiplied by If you look at this term, this the common term here is uh, S, because we'll try to recreate it somewhere here. See, we have just omitted these two rows for the sake of calculation. What we get here is now uh, 0 0, so that is, and 1 0. The common term here is where S is 0, so x into S bar, and these two terms, there is something common here. Yes, it is cube. This should be something like what? Sorry, it should be 1 0. Let's see, what I have done wrong here is S should be 1 instead of R bar S bar. It is R R S, and this would give us, by following the laws of binary addition, we would get uh, q bar x bar into S would be common, R bar plus R, R, sorry. So R bar plus R in any case would always be 1. R bar or R is always, the value is always 1. So S into 1 would give you S at any time. So S and 1 is always S. So what we get here is uh, q bar x bar multiplied by x. This is one term. The other term here is x S bar and Q. So these would be all with each other like this. Uh, do we have anything common here? We don't have anything in common, but we know the terms on one. It contains two uh, SOP terms. The first term is it consists of Q, S bar, and X. The second term consists of Q bar, X bar, and S. So the answer should be, if you remember, should be Q, S bar, and X. This is one term, and the other term is Q bar, S, and X bar. So B is the answer over here. Uh, is this clear, or uh, do you have any doubts in calculating this thing?
So what was the mapping? Uh,
Right.
exactly, what does this solve in terms of logic?
Okay.
This
So in
came.
right. So I'll just take one term, that the first KMAP, the first part, and try to explain the importance of KMAP and how we can use to solve the equations, or the problems in digital combinatorial circuits using KMAPs. We have P Q R S 0 0 0 1 1 1 1 0 0 0 0 1 1 1 1 0. There are certain patterns where Suppose I take a pencil dark enough. uh, to explain. Okay, technical. So these are minterms, we could say, in POS. So what it helps us is that by using this PNS, we could find out the patterns uh, or the minimum of the terms that would be required to determine the terms in SOP. Or so you could minimize the equation very fast or very rapidly, quickly. What does this say is that let me just get back to this sum. We have four zeros at the top, 1001, 1001, and zeros. What it actually is, what this map is actually saying that the original term is uh, we look at the terms in case of SOP, sum of product, the terms that are the cells that are valued with 1. We ignore the terms that are valued with 0. And there is also one case called don't care, which is like we may consider those as either or 0 based upon our ease of calculation. Or to reduce the complexity, we could just take those as 1 or 0. These are called don't care terms, which is basically denoted by a cross. So, if we look at this map, this K-map, what equation is this K-map throwing at us is let us consider the first cell. So, if you consider the first, the cell where there is one, the first cell where there is one, it is where P is 0, Q is 0, R is 0, and S is 1. So, what is saying that this term would correspond to P bar, Q bar, R bar, and S. Or even easy, let me just give you the definition of this cells. We have RS. The first cell where all zeros are there, this would be P bar, Q bar, R bar, S bar. The next term would be P bar Q, R bar, S bar. Uh, the next term is P Q, R bar, S bar. The last term is P Q bar, S bar. So similarly, so it is basically if the term is 0, we have a p bar we denote it with a complement. If it is 1, it is the variable itself, the term itself. So 0 0 refers to p bar and q bar. These 0 refer to r bar and s bar. So if we look at it, the first row will have all r bar s bar. All the terms will be r bar s bar, uh, and the first column it will have all p bar and q bars. So I'll just populate the entire definition map over here for the K maps of four variable uh, a system having four variables. This would be P bar, Q bar, R bar, S. R bar and S because R is 0, so this would be R bar, and this is 1, which corresponds to S. So this is S without a header over there. So maybe this would be P bar Q R bar S. This would be P Q R bar S, and this would be P Q bar R bar S. This is P bar Q bar R S, P bar Q R S, P Q R S, P Q P Q bar R S. This is P bar Q bar R S bar, P bar Q R S bar, P Q R S bar, P Q bar R S bar. So this is the definition map, and what the given equation is saying that uh, this term is 1. So this corresponds to P bar Q bar R bar S. We just write it down over here. P bar Q bar R bar S plus the second term is if you consider this cell, it corresponds to P Q bar R bar S. P Q bar R bar S plus if you consider this term, it is P bar Q bar R S, P bar Q bar R S plus the next cell with the value 1 is this cell, uh, which is like 1011, or we can say P Q bar R S, P Q bar R S. So this is the given equation. Uh, this equation could also be given in terms of uh, numbers or decimal numbers, like um, uh, wait, will this be visible? Okay, so I will have to do it again. Uh, this could also be this equation could also be given in a numerical form, such as we have to consider the placeholders for this. So, is it visible? Okay. So this term is 0. This is because 0001 1. This will be 2, because, or then this will be 3. This is just the decimal equivalent of having this. So 0000 will give you 0, 0001 is 1, 0011 is 3, 0010 is 2. Similarly, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15. If you could see, 1111 binary is 50. It is just, you can take any piece, it would just correspond to the decimal equivalent of the binary number that is created by the header of the rows and columns. So if we consider this, it is 1000, which gives us 8. Or if we consider this cell, it is 0111, which gives us 7. So it's just the values. Now they can also give the same equation as this same system or this same system can be denoted by a number as function uh, function of uh, p, q, r, and s as summation of mean terms, and only some numbers will be given. So here, if we take this cell which has the value 1, they will give just the corresponding number of the cell. So here it is 1. They can just it could be just represented by means summation of mean term 1. The next is 3, which is a non-zero, so, or 1, that is 3. The next is 9 because this cell, specific cell, corresponds to this one. Pencil here. This is a right thing. So if you consider this cell, it corresponds to 9. And if we take uh, with 9 away, and if we take this specific cell, it corresponds to 11. So the same system can be represented in K-map in this way, in a canonical form, or not, it is not exactly canonical form. Yeah, it is canonical form as this way because all the four elements are here, or in terms of numerical sort of representation like this. So these are all the representation of the same circuit. So this is how we multiple sort of representations can be there in the exam paper. So we have. So I think this should be clear enough. Or still, is there still any doubt in this PMR and the equation?
So what I would say, Nikhil, is that obviously it is a sum of products and product of sum, and you are trying to do minterm and maxterm
Yes,
to get to the optimum uh, of the
correct.
variables, right? Optimum of the SOP optimum. So what I would say is it translates into some logic,
Yes,
exactly.
yes,
And that logic means we are trying to minimize the gates,
yes,
correct?
right.
So it's a gate minimization technique, and it can be done as a sum of products or product of sum,
Yes,
and based on the min term and the max term. So there is a process involved, and that is only if you try yourself you will know what it is.
right. There are
It is
certain
difficult to
rules.
explain.
Yeah, so there are certain rules. Like so, if so I'll just consider uh,
Mhm,
four variable system.
mhm,
So if we have something like this or
mhm,
this one, right?
mhm,
We know that the terms will be 111, like
mhm,
0001. Just copying everything for the sake of clarity.
mhm,
Let us consider PQRS again as a terms.
mhm,
So if we consider this block that is in the very center, it
mhm,
would we have to consider just the common term. So here the common term is Q, right, for this pencil. So when we are considering this block, the common term is Q,
mhm,
and the common term on RS factors is S. So we just multiply this two. So in this case, if we are this specific block that is in exact middle is Q, because the only common term is Q, and in the PQ factors, and in RS factors, the only common term is S. So this would be an AND gate between Q and S. Uh, if it comes out of the edges, again the same logic applies. Like if this is the, if we are considering this one, let me have a red pen for this. So if we are having this one, one like this, one and one, then again the common term in PQ is Q, but in RS factors the common term would now be S bar, because the zero zeros under S are common. R variable changes, because R is 0 here and R is 1 here. So R variable changes, but the S bar variable does not change. So in this case, in the red one, it would be Q and S bar. Uh,
Yeah, so this is based on the sum of products you are taking, correct?
this is based on the SOP. Yes.
Yeah, and QoS will be inverse of it almost.
POS, in POS we
Two
consider
will be replaced by one will be replaced by zero, correct?
yes,
Okay.
yes. We invert it, and then or we just calculate, instead of considering ones, we consider zeros, and
Mhm.
we have to uh, instead of an AND gate between this, it would be an OR gate. So if if this had been maxterm,
Mhm.
which is given, or whenever it is an maxterm, it would be given by a pi of m, capital M. If it is
Mhm.
SOP, we denote it by a sigma and small m. The function
Mhm.
would in that form, uh, and in that case, we have a bar. We consider the cells where the values are zero, and those are uh, product of sums. So in
Mhm.
product of sums, instead of uh, having the KMAP definition would actually change to to instead of like it would be P or Q. So the and sign changes to an or sign, and here the first term would be P bar and R bar plus S bar. And we consider the terms where the values are zero instead of the where the values are one. In POS, we consider the cells where the value is zero. That is how we start. Uh, and try to have look for some numerical
Mhm.
sum of products. POS is rare. I mean, it is less frequent than SOP. I think it's,
So
um,
maybe you can look at the geek, which I have put in the link.
okay.
There's a link I have put there. There are some problems and solutions. Maybe just click on that on the chat window and just view it so that people can actually look at some of the problems that are expected types. Like quick.
Um, yes, yes. I'll just switch to this screen now. Um, Then SOP representation. Minimizations.
Yeah, you don't have to solve anything, but just to mm, take a look at it, what is available and what questions types are there. So to give you an idea that you get a lot of variations in this.
Yes, yes, there are a lot of variations. So there could be a circuit design minimization or
Correct.
yeah. So let me check this one. What
Hmm.
this is actually a very simple thing, but we'll
Hmm.
have to create what do we say? Um,
Hmm.
a truth table for this,
Hmm.
and we can find out what's happening. So basically,
Hmm.
what is uh, going over here is this is an AND gate, this is a NOT gate, which inverses the value. This is an OR gate. Uh, and when we have inputs as A, B, C, when A and the Z here is A or B bar uh,
Hmm.
dot C, because this is a B bar and C, uh, this inverts the B. Uh, it goes in and uh, it goes into an AND gate for which
Hmm.
the other input is C. So the output of this AND gate is B bar dot C. This input goes into the OR gate where the other input is A. So A OR, which is denoted by a plus sign, B bar dot C. This is the equation uh, of this system.
Of Z.
Yes, of Z. So
Mhm.
we know that whenever A is 1, right, the
Mhm.
output will definitely be 1. So in what case
Mhm.
A will be 1 is all the higher terms that are greater than that are 4 and greater than 4. So 1 0 0, 1 0 1, 1 0 1 1 0, and 1 1 1, which correspond to 4, 5, 6, and 7. So we have two terms here, which in which the main term includes the values of 4, 5, 6, and 7.
Mhm.
Uh, Now we have to check this AND gate. This AND gate will only be 1. The output of this AND gate will be 1 only when B is 0 and C is 1.
Correct.
So when B is 0, uh, the and C is 1, it will be 0 0 1. There are two possibilities. When B is 0 and C is 1, that is 0 0 1 and 1 0 1 for A, B, and C. So this gives us 1 and 1 0 1 is 5. So the terms that we have now, which satisfy the circuit, is 4, 5, 6, 7, 1, and 5, which is already there in the which we had already found out in the previous block, the OR gate.
Correct.
So the output is here is 1, 4, 5, and 7. This should be the correct answer.
See, it is giving two choices. Why is that means this is eliminated? The third one,
Yes, yes,
because of it is being two, correct?
right.
And it cannot be two. It can be one or five, and so one is the only option,
Yes,
and so two is not an option. So that solves the solve. So, okay. So
yes.
this is what this is called as minimization, or
Minimization.
okay. So the min term and max. What is the meaning of that? Uh,
Uh, so
there
let me
is.
check.
See, we talk about min term and max term, right?
Yes.
we talk of SOP and POs that we have understood, sum of product and product of sum, right?
Right.
Sum of product is more related to ands or and product of sum is more related to ors,
Or
correct?
so product SOPs
Mm-hmm,
is the individual terms, the smaller terms
mm-hmm,
are products,
mm-hmm,
and they are ORed with larger terms.
mm-hmm,
The OR operation uh, takes place when smaller terms which are added with each other are
mm-hmm,
combined using an OR gate. So that is a sum of products, which is
mm-hmm,
mean term. Sum of
mm-hmm.
products will be mean term. Uh,
Okay.
again, so which we normally use like ABC plus A bar B C. So
Mm-hmm,
these such sort of uh, combinations, they are mean term combinations, or
mm-hmm,
and they are because if you see that ABC is a product
mm-hmm,
or A B bar C, this is
mm-hmm,
another product. So it says that it these products are summed together, which is like a sum of products SOP, and these are denoted by a sigma and n. Uh,
mm-hmm,
when it is a product of sum, the smaller terms are sums, the smaller terms. So A
mm-hmm,
plus B plus C bar,
mm-hmm,
and the other term, the smaller such would be the smaller terms, and these are combined together by AND gates. So
mm-hmm,
A plus B plus C bar is ANDed with say A B C.
mm-hmm,
So these are sum of products, and the term here are called as max terms,
mm-hmm,
and the function would be denoted by a pi sign. In
mm-hmm,
in product of sum, it is pi. In sum
mm-hmm.
of products, it is sigma.
Sigma. Okay.
So a keyword that I use is like S starts for sigma. So SOP is sigma. Product of
Mm-hmm,
sum is it starts with P, which is pi,
mm-hmm.
and it so product of sum would be denoted by a pi sign. That
Is
is
there
the
a here going? Is there any pi indication here in this
here.
check?
So
Usually,
this
it's not very common, right?
it is
Uncommon.
not very common. It is
Correct.
uncommon.
Correct.
Uh, so actually, this is a product of sum.
Mm-hmm. Okay.
This representation is a product of sum representation. Uh,
Mm-hmm.
X plus Y plus Z, or X bar plus Y and
Mm-hmm.
Y bar plus Z.
Mm-hmm. So it
So
is a product of term of three expressions, right?
yes,
Okay. So there is difference between product of sum and sum of product. Sum of product is more a ORing,
yes,
which is in each of the F is equal to product of sum of product into sum of product 2 into sum of product 3, correct?
right,
So that's the way we look at it. Okay. At
yes,
least some idea gives us some idea that you can have a combination of the two in the expression, but we have to solve each separately and then come up with the conclusion, right?
right.
Okay.
So
That gives some idea about the logic of the K map for minterm and maxterm.
yes,
So minterm relates to summation of product and maxterm relates to product of sum.
yes, that's right.
So one has to really try it out oneself before one can really achieve the what you call the understanding. It's a
Yes.
little complex, but this is the one. What is the amount of scoring you get on this one gate in gate usually? Quite
So
a bit.
this is quite a bit. It has good amount of scoring. Uh,
Correct.
so like in 2014,
Mm-hmm.
uh, this digital circuit has uh, 14 questions,
14.
14 numerical types.
Mm-hmm.
With numerical types? Yes. So there are 14 numerical types.
Mm-hmm.
Yeah. Questions were asked in 2014. Again, in
Mm-hmm.
2015, we have um, 25 minus 21.
Mm-hmm.
So that is again 14.
Mm-hmm.
So
So around 15 out of 100 marks is based on this. Is
uh,
that or more?
more,
Is it
more.
one and two? Right. Some of them are score one. Some of them are
Yes, yes,
two.
some of them are true.
So
So
basically, it is important to cover this to get the logic design correct. Right.
yes, this is a very
Most important.
important. Yes,
Hmm.
this is, I think, and it is a foundation for electronic circuit design. Uh,
Correct. So
so
minimization of circuits is a really a
yes,
challenge, and
yes,
understanding K-map with POS and SOP is SOP and POS is important. And there are some terms they call it pitfall or something. I don't know. You can look at it to remember something. There are some like try to in the geek you can see in that some of their how to solve, and there are some simpler notations to understand and remember. So those are important. But all in all, I think this is a good job, excellent job from your side to at least bring the people to understand what this K-map stuff is and how to use it and how to leverage it to get some additional score.
yes. Because PMAP, it seems very difficult to understand, but
Mhm.
it is
Graphically, if you do graphically, it is easy. But
yes,
if you try to, so the understanding how to graph it is more important than actual
yes,
solution. Then and then trying to turn it into variables to map to variable is very important.
yes. So that will come with practice.
Yeah.
And I had done a lot of practice on
Hmm.
this K-maps. Uh,
Hmm.
uh, Understanding and start. I think a better part will be starting with three variables, building K-maps from three variables, and then moving on to four variables.
Hmm.
It will be more easy to understand. Again, there are some basic patterns which uh, where you can understand if the uh, uh, like looking at the K map, you could find out if there is a NAND gate or if there is a NOR gate or XOR gate and uh,
Hmm.
such sort of combinations just by looking at the K map instead of.
Hmm.
So this is a very good tool. Uh, I think you should always make it a point to master K maps
Hmm.
because it reduces your calculation time. Although
Hmm.
if you know how to build it, uh, finding out the final solution, minimizing the equation is it becomes very easy. Otherwise, you'll have to perform those steps on using pen and paper, and there are chances that there could be mistakes while transforming equations uh, in, in in one of those steps. So KNAP is always very good. It if you master it, it provides a good tool. Again, whatever options are there, you could just verify those using KMaps. If you know how to build a KMap, it would be like very quick operation rather than going through each of the steps.
Super.
So,
Anything more to add today? Or
I think this is fine
Mhm.
for today. Uh, I think we did a lot of in-depth into KMaps,
Correct.
uh, and we could ask our audience to practice the KMaps and find out what uh, operations are there, or try to minimize some uh, equations.
Excellent. So I think With that, I will end the recording. Stop the recording.
Yes.
Hey, thanks. Jaimit, any questions from your end? Last before I.
No, nothing from my side. Right.
Okay,
Okay.
I'll stop the recording.